One of the best ways to get real-world hands-on experience, as well as make money in the Web3 industry, is freelancing. In today's video, we're going to be continuing the series where I go over real-world freelancing projects. In this video, we're going over the staking portion of a project that I had actually completed. My name is Anthony with the Blockchain Dojo, where we turn you into a Web3 and blockchain ninja. Please like and subscribe and stay tuned for more content. Let's get started. Before we get started, I wanted to go over a few specific requirements that I was given for this contract. This was a fixed reward rate, so that no matter how many tokens the specific user put in, they could only stake for X amount of duration, and they would only receive X amount of tokens in reward. Along with that, there were cutoff tiers for the staking amounts. So depending on how much tokens were staked would depending on the reward tier and reward time, as well as this contract is pays out USDT instead of the reward token. Staking contract here, what we did was, of course, declared the license identifier in the Pragma version. I imported the ERC20 token that we'll be staking, as well as the iERC20 interface. From here, we declared the contract lock tokens, the address and the owner, the target ERC token that will be staked, then we keep track of the total locked amount of tokens, and then the USDT, which is the reward token. As mentioned, that there were a few specific criteria for this smart contract, as well as specifically the tiered cutoffs for the staking amounts. So this is actually where the cutoffs happen. So 75,000 staked tokens times 10 to the 18th power, which is the number of decimals, would be the tier 1 cutoff, and then all the way down to the tier 6 cutoff. Next, we specified the locked times, and this would be for the 3 different locked time periods that were available: 180 days, 1 year, and 2 years. From there, we also have the reward rates, and this is based on each tier per the staking time period, going all the way down from tier 1 to tier 6 for month 6 to month 24. From there, I created a struct for the lock amount. Now this would keep track of the locked tokens, the time amount, timestamped of when it was locked, and then the reward amount. From there, I create a mapping of the lock amount to the locked, or addresses to the lock amount struct, and this is going to keep track of each individual user's stake amount. I then declared 4 events: tokens locked, tokens withdrawn, rewards paid, and locked canceled. And then in the constructor, we pass in the staking token address as well as the rewards token address. We assign the owner variable to msg.sender, which is the deployer of the contract. We then assign the KPN variable to the staking token that we passed in, and then the USDT variable to the rewards token passed in. Now this staking contract is a little bit different than, say, a normal one, being that this staking contract has fixed supplies and very specific reward payouts based on the time frame and the amount sent. So with that, we did a few require statements to just verify that the contract has tokens, that the function call has tokens to stake, has the minimum amount of tokens to stake, as well as has a specific time frame passed in. We then, this right here, we then check to see if the current address or current message.sender has an active stake. If they do have an active stake, what we do is we refund the stake amount and then set the locked balance for that msg.sender back to 0 and essentially delete out the struct and the mapping. Now this is only if they already have tokens staked, as that this is only if they have tokens staked, as they would need to have the tokens refunded before they can stake more. From there, we verify based on the amount and the tier cutoff. From there, we have an if and else statement just to go through the different amounts and tier cutoffs and timeframes. And then what we do is we calculate how much they sent in and if they sent extra over the cutoff. And then we take the extra to refund back to them. And then we have the reward amount, which is an internal function, which takes in the time frame and the lock amount to calculate the reward payout. And then we create a new lock amount struct to store the current stake information. and then we assign that to the mapping for the locked balances of the message.sender. And then, of course, what we do is we transfer from the user to this address. And then the rest of the else if clauses just check to verify the differences between the lock amount and the time frame for staking. After that, we have the cancel stake. Now, cancel stake is very similar to the if statement, where we check to see if they already have a stake, already have token staked. As what we do is we check to make sure that the time frame hasn't passed yet, that they have funds locked. Then we grab a local instance of the locked up token amount, and then we require that the balance of the contract, this staking contract, is more than the amount of tokens that they're looking to withdraw from the stake. We then decrement the total tokens locked by the token amount. We delete the locked balances of the message.sender, and then we do a bool success as the return variable for the KPN transfer to send the tokens back to the message.sender for the token amount. We also then require that that bool is successful. If the bool is unsuccessful, the entire function will revert, and then we emit the lock canceled event. The next function we have to go over is the withdraw locked function. So similar, we want to ensure that the current block timestamp is greater than the lock time plus the timestamp of the locked amount struct. Then we require that the balances, that the MSG.sender has funds staked, grab a local instance of the token amount, and then require that the contract balance is greater than the token amount so that they can actually withdraw the tokens. We then grab a local instance of the lock struct. We decrement the total tokens locked by the token amount. We delete the locked balances, and then we approve that the tokens can be swapped from this address, and then we transfer them from this address to the message.sender, and then we pay out the USDT, which is an internal function created, which we'll go over shortly. And then we emit the tokens withdrawn function. Next, we have the pay USDT function, which we call right up here. The pay USDT function takes in a target address and a rewards amount, implements the Open Zeppelin interface for ERC20, and then transfers the target reward amount to the user. Next, the calculate reward amount is just a quick little function or algorithm to go through what the specific reward amount is supposed to be for an individual lock function. We're not going to go too into depth in this. It just ultimately just checks if the stake amount is greater than the tier cutoff, and then if it is the time frame equal to lock time 1 or lock time 2 or lock time 3, and then we return the appropriate reward payouts based on those qualifications. The set USDT address is pretty straightforward. We are just updating the ERC20 rewards, the USDT, for a new address, should you want to change it. We get a staked balance to return the individual staking amount of each individual user. We have a get owner to return the owner of the contract, and then set tier rewards for 1 through 6. And this is very similar to the setting the USDT address. It takes in 3 uint variables. It checks that the message.sender is equal to the owner, and then it updates the specific tier payouts. We went over a lot of information there and really reviewed a staking contract. In the next video, we'll be going over testing for both the airdrop, ERC, and for the staking contract for this specific freelancing project. If you learned something new, please like and subscribe, and stay tuned for more content.